Cool. So we're talking about data modeling in the era of the data lake. So I'm guessing people have heard of data modeling. I guess you've heard of data lakes, lake houses, since you're attending this. If you haven't, stay tuned. So a little bit about that worked. There we go. There we go. This is me. So Matt Housley, you want to stand up real quick? Matt and I wrote this book. It's like we had a kid that looks like a bird. So anyway, that book took off. It became really popular. And yeah, other stuff about me. I call myself a recovering data scientist. That's partially true. So data engineering and architecture. Nowadays, I travel the world giving talks and all that kind of stuff. I rock climb once in a while and DJ at places. So, but that's not why you're here. So Lakehouse, arguably, we're going to talk about this, but it is the next evolution of analytical data architectures. I'm going to talk about why it's a lot more than that, actually. Data modeling is making a comeback. Some might say it never went anywhere. I say it kind of died for a bit, but it's coming back. I'm also writing a book on data modeling. So this topic is top of mind for me right now. So, and I'm going to try and get through this pretty quick here. So why talk about data modeling right now? You would think this is a well-worn topic. I mean, Edgar Codd came up with the relational model back in 1970. I think that was a long time ago, 54 years now almost. New York City back in the 70s was a much different place too. But a few motivations, right? So the rise of AI means data is getting a fresh look. Whose company wants to do AI right now? Okay, yeah, everyone's reluctantly holding their hands up. Yeah, I guess. Well, we'll get into that. Who feels their corporate data sets are awesome and clean and don't need any attention at all? Right? Yeah, you? Okay. Go. Good for you. So I mean, these are some of the motivations. I think with the attention paid to AI, especially, this is the time when a lot of money and attention is being put onto data. So it offers a new opportunity to maybe get a few things right that we've been sort of pushing under the covers, like data governance and management and all the hygienic practices that we always complain about that nobody's doing, but we somehow never seem to do them anyway. You have the money to do it now, right? I'm going to make a strong argument that if you can't get your data correct in this case, then AI is going to be kind of a flop for you. But let's get going. So what we'll discuss. First, let's talk about what a data model is. I think there's a lot of definitions out there, so it's worth discussing sort of what that means, the evolution of data architectures, and finally, data modeling in the era of lake houses. And so let me just open this up here. What's a data model? What do you think a data model is? I'll spend about a couple minutes on this. Anyone? Yes?
Representation of your information.
I like that. Yeah. Representation of your information is what he said. I like that a lot.
And your consumption.
And your consumption?
Yeah, how you're going to query it.
Yeah, that's a big piece too. Absolutely.
Contract with the data users.
Yeah, I like that. It's contract with data users.
Making
yes.
It's a representation of your business.
Representation of your business, right?
Making it human readable.
Human readable.
This.
Relationships have been made. Yeah, so awesome. Right, we're talking everything from representations of business to information, contracts, queries. So let's look at a few classic things. I like to pull up this old trope from William Kent. This is from Data and Reality in 1978. I think this was maybe the first attempt to describe data modeling and data. How do you interact with data in computer systems? You got to remember back in the 70s, computers were a lot different than they are now. I mean, your phone, everyone has one of these. These are pretty powerful. Back in the day, this wasn't the case at all. And I think people were philosophically thinking about how do you model reality in computer systems, right? And I still think this is the case. Every time we touch data, we're actually doing this. But here's a few quotes here. I'll let you read them. So notice even back in 78 what he's not talking about, right? He's not talking about data modeling is the relational data model from Codd, right? It's a bit abstracted. But let's go to another one. This is from Steve Hoberman. Who's heard of Steve Hoberman, by the way? He's arguably one of the OGs of data modeling in the world. This is how he defines it, right? Data model is a wayfinding tool. I'll leave you the rest. So the definitions mature somewhat, right? Now we're talking about business and IT professionals and the organization, i.e. the business, right? And so now I think this came out in the 2010s, I'd like to believe. Steve, I've talked to him on numerous occasions. He refines his definition of data model. The latest one includes the words precision. I forgot to write it down because it'll be on a podcast coming out next week, actually. But even here, right, precisely explain a subset. So that's an interesting twist. How often do you feel like you can precisely explain things in your business through a data model? So that's how Steve views it, right? Here's how I view it, right? That's the working definition of data model from my new book. A data model organizes and standardizes data in a structured representation to enable and guide human and machine behavior, inform decision-making, and facilitate actions. This, I think, updates the definition of data modeling for the 21st century and especially for the age of AI. We no longer, I can make a very strong argument, we actually very rarely lived in an era where humans were the things consuming data. It actually, computers, even in the 70s, I mean, you were writing applications for computers to consume data, not humans. That's why you would automate things. It was when analytics came about that we started taking a human-centric viewpoint of data. I think that this is an important distinction. But with the rise of AI, I sort of wanted to future-proof this in case AI gets angry at my definition. But you're no longer living in a human-centric world. You're living in a world of intelligent machines and machines that are going to get more intelligent, right? So you're facilitating human decision-making and possibly machine decision-making, but also actions. Sorry, hold here. There we go. So the evolution of data architectures. Let's talk about this next. So we're going to go over a couple of things: the warehouse, the lake, and the lakehouse. Everyone familiar with these concepts broadly? Lakes, warehouse. Okay. So before the data warehouse, right? We're talking about analytical data structures now, architectures. Databases are mostly mainframes. You had to query them. Can you imagine what happens? Who was around back in the day when you had to query these things? Maybe somebody here. I talked to people that had to do this. In fact, Matt and I had to query a mainframe once at an old client. Very fragile. I don't want to run analytical queries on that. And so the other thing was data was very scattered and hard to find in these corporate systems, right? I mean, if you remember IBM DB2 databases, they were limited to like 7 character columns. So just finding data in those things is a bit atrocious. And the question was how to run analytics without disrupting the transactional systems, right? So, and again, centralizing data. This was a new concept. And along comes a data warehouse, right? So this is I think the classic rendition of Bill Inman's data warehouse, right? So taking data from operational systems, storing it in a warehouse, and then having data marts to serve various domains, I guess as we now call them. These used to just be called departments, like what we get, purchasing, sales, inventory, and so on, right? Who's seen this before? This is the canonical data warehouse. And I think the interesting thing is it's sort of been co-opted by companies and marketers to mean other things, but this is the classical architecture for a warehouse. And actually, this is how Bill defines it. This is Bill Inman. We become a kind of, he calls me his little brother. I call him his big brother. But a data warehouse is subject-oriented, non-volatile, integrated, time-varying collection of data in support of management decisions. Right? This was the classic motivation for a data warehouse. This is the canonical definition. And what's interesting is what's not discussed here. What's up? Right, he's not talking about an implementation of it. It's an architecture, right? It's an approach again to support management decisions, analytical decisions. So this was the motivation for the data warehouse. And he actually, interestingly enough, he came up with it on a whim. He was writing an article for Computer World and thought, oh, that would be interesting if you could like actually separate out the analytical stuff from the transactional stores. So all this stuff sort of happens by accident. And the term data warehouse, actually, he was telling me, it came about in a meeting, I think at some oil company up in Canada. A woman had said, oh, let's call this a data warehouse. And they're like, oh, that's kind of cool, let's do that. So, and there we go, right? So it's just kind of funny how a lot of this stuff, and he also told me, actually, it's interesting, the data warehouse actually almost never happened. He was working at a company that was working on it, and they said, oh, this is stupid, we don't want to invest in it. So he went off on his own and did it. So it's interesting to see how these like sort of, the industry takes different turns almost randomly. So the data lake, right? This was, I think, the late 2000s, some would argue maybe earlier, to the mid-late 2010s. So the attempt was to centralize data for use for data science and analytics. Data science came about, and now you have basically, structured, semi-structured, unstructured data that could be used for analytical and machine learning purposes. I suppose we're going to get into the punchline in a bit, but can people guess what happened with this? If you're giving everyone access to data, I think that motivation's good. The goal is good. What happens is, well, I'll back up. The big data era was also an interesting one. I think this caught the world by storm. Every company suddenly wanted to start doing big data systems. So you'd see companies with like data sets in maybe the megabytes or gigs, spinning up Hadoop and doing MapReduce on them, which I suppose you can do that if you want. And so a lot of these data lakes started proliferating. And I think the consequences or the challenges with the data lake / swamp, you have unorganized workflows. Who's actually experienced this? Who was around in this era and was working at this time? Am I giving you PTSD? Okay. No standardization for querying or storing data. You started seeing engines like Spark come about and others to make it easier to query, but there was no underlying schema management or centralization of like, there was just no practice. It was kind of like anarchy. Data management and governance is pretty much non-existent. It was hard to find ways to, I think, coherently govern data. And with the rise of GDPR and other regulations, now you have these things called deletion requests. Good luck going into your data lake and finding the data for that deletion request. And so what happened was data hoarding. Right? Whose company or who has seen data hoarding before? I will show you a picture of somebody. So this is a data engineer. He's 25 years old. And this is an example of the data lake that this person gets to manage. So yeah, this might be, I don't know, you can get the idea. So, but it's a lot like this, right? You want to hold on. And the old argument was, oh, we're going to keep the data because we don't have any idea when we might need to use it later. This person says the same thing about that pizza box sitting in the corner over there. So a complete mess, right? And then you start seeing the kind of the reversion back to the quote data warehouse of the modern data stack, which we'll cover in a bit. But wait, one more. The Lakehouse, right? Enter the Lakehouse, and I think these are sort of the fusion of the best of the data lake, not the worst, and the data warehouse, right? So providing a coherent structure for analytical use cases, but it was much more because you can store semi-structured, structured and unstructured data in one place in a way that's governed. You can get a lot more utility out of it, right? And so you just start seeing, I think, a lot more advancements in terms of storage, query engines, and so forth, in a polyglot sense too. No more you can find to combining your compute storage, right? You can separate these out. You can bring whatever file format or table format you want, whatever query engine you want, and it just works. They laid out some awesome architectures in that previous presentation. Kind of showed the possibilities of this, but this is the future and it's the present, right? So it's about openness. So. Sorry, I can't do this anymore. Okay, so now you have tranquility. Did I do that or did you do that? Okay. Again, the evolution for the warehouse, the data lake, to the lakehouse. All right, so let's talk about data modeling now. What's that? Okay, here we go. I'm going to look at three main use cases, right? So operational analytics, business analytics, and machine learning and AI. So who's familiar with operational analytics? These are basically analytics that you're going to do in a rapid fashion, right? So it lends itself really well to streaming data, for example. Streaming equals rapid response, real time, which can mean a lot of things to a lot of people, but coupled with intelligent automations, right? So this is where you start bridging the gaps between either heuristics or machine learning and AI feedback loops. In a lot of cases, with these new table formats, there's ACID, right? So you actually have transactional guarantees now, which is pretty cool. No longer do you have to guess if the data is correct that you're querying. It will be. And schema flexibility, this is a really big one, right? So I think who's worked in a place where you've had to wait 6 weeks for a schema update or a column update or something like that? You have? Okay. Were you the one requesting it? Okay. Yeah, so this is the reality, right? But now it's changing. Right. All right. Business analytics, right? So I think back in the day, especially when I showed you the Bill Inman architecture, that was purely batch. But now you can do batch and streaming. So why not both, right? Pick the combination that works for you. Again, ACID guarantees for data correctness. Schema flexibilities means no more waiting, again, 6 months for a column to be added to your data warehouse. You can just kind of get moving. This means removal of bottlenecks, right, and faster iterations. And now you can model however you want, right? You can bring your Kimball, your one big table, your just a bunch of tables, your data vaults, your whatever. Who's heard of these techniques, by the way? Like Kimball, show of hands. Data vault. One big table. Just a bunch of tables. No tables. I think it's called query-driven modeling is what I jokingly called it on Seattle Data Guys podcast. So, I mean, yeah, you can bring whatever use case you want. I think back in the day, you were actually shoehorned in due to system constraints in terms of the data model that you could do. But now you can kind of do whatever you want. Data modeling with machine learning and AI is an interesting thing. So most people don't consider this to be data modeling. I do, according to the definition that I shoehorned it into earlier. So there's classical machine learning. So I call that anything that's basically pre-gen AI. That's kind of a joke. I also joke that we're in a classical machine learning winter right now, because like anything that's not generative AI is kind of lame and old hat. So, but it still works, right? I mean, there's still valid techniques. I mean, who does forecasting here? So there's some people, right? I mean, that's kind of staple, and I don't think a large language model really does that. It's not meant for that, but you know, where we're going though is multimodal machine learning, right? So images, text, video, audio, structured data, right? So this is data that's in your databases, in your data lakehouse. There's a new term you'll be hearing more about, large multimodal models, not LLMs, but LMMs. This is where everything's going this year. And you know, corporate data models will finally incorporate unstructured data. And in fact, Bill Inman, after he invented the data warehouse, it was interesting. He kind of moved on from it because he realized, like, you know, 5 to 10% of your data in the business is structured. The rest of it was text. This is back in the 90s, right? So he's thinking, well, okay, so we're trying to unlock a lot of these tiny data sets, and I'm missing the bigger picture of emails, documents, and all this other stuff. So I think that this vision is finally going to be realized, right? But it's not just text anymore. You know, we're going to be combining images, text, video. There was an interesting one I saw the other day, an article where some police departments were going to start scanning body cam footage with AI to see what they'd captured. I think that's interesting and also kind of mortified to see what they find out. But that's an example of what you're going to start seeing. I think that a lot of companies just have all this unstructured data that's just been sitting latent, and starting to combine that with the traditional BI use cases is going to be fascinating. So again, why not all the above, right? Matt and I actually called this the live data stack in our book. So it's a recognition that as feedback loops get shorter with streaming, as the lines between software engineering, quote, data analytics, and machine learning get blurred, there's an argument to be made that you'll actually see no separation between any of this. They'll just become, quote, data products. And there's also the rise of HTAP, so hybrid transactional analytical processing in the mix here too. So the challenges for data modeling, I would say it's the same as before. It's usually organizations and people, right? So I actually find there's a huge lack of knowledge with data modeling, no matter where I've been in the world. And I feel like the body of knowledge for data modeling really stopped around, was it 2000 with the publication of the first Data Vault book. There's been adaptation since then, but I've not seen anything new since then, which is one of the reasons I'm working on this new book. I actually feel like the world of data modeling went backwards during the modern data stack era, not forwards. What was once a discipline that was widely adopted and people had skills in data modeling disappeared. It was like an entire civilization went lost. But now we're bringing it back. So, who's heard of Conway's law? This is sort of the inevitable gravitational force in the universe. Basically says that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So if you work in a very siloed organization, guess what kind of systems you're going to produce? Very siloed systems. Yes. If you're very open, you'll have a more flat architecture, right? And so I kind of made this up the other day. So basically, it's a transitive law, and it's supposed to be a joke. But any data model will ultimately be structured according to the organization's systems and architecture, meaning that the physical data model will inevitably have to be shoehorned in to your existing architecture. And what does this mean for the Lakehouse? Well, this means that you have immensely more flexibility with your data models because you exist in a heterogeneous world of both data and approaches to modeling data. You're no longer limited by specific approaches, right? So what I often see is in a data modeling world, especially, is it's very religious and contentious. I'm not going to name names. We can talk about it at happy hour later if you want. But the future is what I call mixed model arts. It's a quote from Bruce Lee. So use that which works and take it from any place you can find it. And also don't deny the classical approach. Simply as a reaction. We have created another pattern, and you'll be trapped there too. So I consider him to be the founder of mixed martial arts, the UFC and stuff. So anyway, that's the talk, and I think we're about at time actually. So hit me up on LinkedIn if you'd like to meet you there. That's my Substack, a weekly newsletter there, and let you get a picture of that real quick. But wait, there's more. Okay. And sorry, one more slide. There we go. Oops. This is practical data modeling. This is where I'm going to be publishing my new book. So if you're interested in, we have almost 3,000 members in the community right now. We have a lot of chats. I would say it might be the strongest contingent of data modeling discussions on the planet. From a lot of the strongest data modelers on the planet. So if these interest you, Dan shaking his head, he's there. Thank you for being a part of it, by the way. It's awesome. Yeah, if this interests you, then click the QR code and sign up. So thank you. I have time for one question. Yes?
Will LLMs be great influence on the whole data modeling world?
Yeah, I have a couple thoughts on that. I think that LLMs, it's going to be interesting. I think that and I've been doing some experiments with this. I feel like there's an opportunity for LLMs to actually help introspect existing data sets and convert them to a more proper data model. I also feel like the other way, you could probably generate DDL to create a data model as well. So I think it works both ways. Yeah, I think you're starting to see that. Yeah. especially when coupled with knowledge graphs, right? So it provides the context. My friend once did some research on large language models, and on their own, if you're doing especially text to SQL, these things hallucinate like crazy. I would not use them in production. But when you couple it with a knowledge graph, you get to about the equivalent of a coin flip in terms of accuracy. So awesome. It'll get better though.
I mean, even that you don't need modeling anymore. LLMs is just gathering information and finding out relationships internally.
Yeah.
In quite a different way than human modeling or whatever.
Yeah, and I guess it's a question of like how much you want to abdicate that responsibility of understanding your business to the machine. In some cases, you probably want to, offload a lot of that. In other cases, especially if you're doing analytics, you kind of want to understand the domain in which you operate in. So I think it depends like how much you want to automate versus understand. So what I'm hoping for analysts, especially, is this makes analysts more focused on causal questions like why and how, not just what, when, and where. Right? That can be automated. So cool. I know it's break time. Thank you.